So 2-element array is okay. Any questions regarding 2-element array? Okay. So the basic idea is to change the direction of the maximum radiation. It is no longer required to physically rotate the antenna. It can be done without any moving parts by simply changing the value of alpha. The direction of which where we want the maximum radiation, all we need to do is change the value of alpha. Let us extend this relation to n-element arrays now. Same similar logic. This is antenna 0. This is antenna 1. This is antenna 2. Goes on. This is antenna n minus 2. This is antenna. And since, once again, since this distance is much larger, this d between two successive elements is d, and this is r0, we assume that r0 is much larger than d. Okay. So this will again be d cos. This distance will be d cos phi. This additional distance will be 2d cos phi. This additional distance will be n minus 1 times d cos phi. Okay. And instead of phase angle of change of angle alpha, now we do it minus alpha, I0 minus 2 alpha. Here I0 minus n minus 1 alpha. Okay. Is it clear? So this is how we change the excitation. Instead of alpha in all, first and 0th element has I0 0 degree. First element is I0 minus alpha degree. Second element of I0 minus 2 alpha degree. N minus 1 will have I0 minus n minus 1 alpha degree. Is it okay? This is how we excite the n elements of the array. Okay? Is it okay? Right? So first element is, so 0th element, just like C, we start our element, that we start our array with 0th element. Excitation is I0 into 0 times alpha, that is I0 0 degree. First element I0 minus alpha. Second element I0 minus 2 alpha. Similarly, last n minus 1 element, we have I0 n minus 1. Okay. So this is how, this is the excitation of the n element array. Is it okay? Right. So we come back to the same equation, E total equal to now E naught magnitude of 1 plus j psi 2 j psi n minus 1 psi. Psi is once again kd cos phi plus alpha. Is it okay? Same analysis as the 2 element. Same thing now extended to n elements. See, if the first two things 1 plus minus j psi is in the 2 element array as well. Can we write this? Okay. This is a GP series. Remember from school, high school, sum of GP series. So the sum of this 1 plus z square up to z to the power n minus 1. what is the sum of this quantity? This you have learned in school. What will be the sum of these quantities? Anyone? Obviously, no, doesn't matter. That can wait. What will be the sum of this quantity? Anybody? Yes. Right. Not two real one. Yes, exactly. The sum here will be z to the power of n minus 1 by minus z. Okay. So same concept we can apply here. E total, this will be E0 e to the power of minus jn psi minus 1. Right? We can write this. Or just basic better. 1 minus e to the power of jn psi minus 1 minus. Right? This will be E0 we can write this. We can write this. Okay. This is equal to right. The magnitude of this quantity is 1, so we can neglect it. This is equal to, is it okay to write this? Think carefully and then tell me. Is it okay to write this? Right. Let us check. If n equal to 2, if n equal to 2, then this will be E0 sine of psi by sine of psi by 2. Right. This can be written as E0 2 sine psi by 2 cos psi by 2 by sine psi by 2. This gets cancelled out. That is 2 E0 cos psi by 2. Remember, this is the same expression which we had for two element array. Right. There is a previous section when we discussed the derived two element array, we got the same expression. Okay. So it works. Hmm? Same as what we had seen for two element array. Correct. Great. in general case, E total, that is E0 sin n psi by 2 by sin psi by 2. When this is maximum, when this is maximum, for what value of psi this is maximum? Pi. Uh, think carefully. Okay, Ritika is saying 0. Yes, 0 is okay. You can tell me the value of n for which. And yes, 0 is the right answer. For 0 it is maximum. And what is the value of what will this value give at 0? Because if you put psi equal 0, then is sine 0 is by sine 0, that is 0 by 0 is infinite, right? So let us use limits. What is this limit? Limit. Exactly, undefined form, so we have to use some limit. So psi tends to 0, sine n psi by 2, right? Sine psi by 2. So we can write limit psi tends to 0, n times sine n psi by 2 by n psi by 2 into psi by 2 by sine psi by 2. We can write this. Okay to write this? We can write it in this way. Is it okay to write in this way? Right? Yes, actually, yes. If you do it in that L hospital rule, you can get that. Fine, that is also correct. You can take the derivative, get cos, okay? No problem, fine, absolutely right. I am trying to do it another way, okay? So see, this is equal to form of, this is in the form of sin x, limit sin x by x, that is 1, okay? And this is the inverse of that. So this is n into 1 by 1, that is it. So the maximum value here is n. The maximum value here is n, right? Yes, your method is also correct. You can give the derivative of both sides, okay? It will come cost, put the value. The answer will be n anyway, okay? Agreed? Right? So the maximum value of this is n, right? And for what value? Once again, we can have broadside and end fire patterns on same logic. We need to have for maximum radiation, psi should be 0 or kd cos phi plus alpha should be 0, okay? For broadside, pi should be pi by 2, okay? This means kd into 0 plus alpha equal to 0. This means alpha is 0. Once again, all the elements must be fed in the same phase, okay? For broadside. For end fire, kd cos 0 plus alpha equal to 0 or minus kd plus alpha equal to 0, sorry, kd. So alpha equal to minus kd. If d is equal to lambda by 2, then alpha will be minus of 2 pi by lambda into lambda by 2, that is minus pi, right? Okay. So once again here, by changing the value of alpha, we can change the direction of the maximum radiation. But notice that the magnitude of the maximum radiation is now n. N. So more antennas, the narrower will be the beam. We will see this in the we will see this in the next class. We will in MATLAB after will really verify. Okay, more the number of antennas, higher is the gain, or narrower is the beam width. Right? Where can you find the nulls? Zero radiation. Tell me. For what values of psi is this quantity zero? Obviously, not for psi is zero. There we are seeing maximum. For what values of psi, this value is zero. Anyone? For what values of psi, this quantity will be zero. 2 pi n. Okay. Or other words, it is the even multiples of pi. Okay, let us check. This is zero when sin n psi by 2 is zero, but sin psi by 2 is not zero. Then only this will be zero when sin n psi by 2 is zero, but sin psi by 2 cannot be zero. Okay, sin n psi by 2 is zero when n psi by 2 is equal to n pi, or psi is equal to 2n pi by n. Similarly, this is zero when psi by 2 is equal to n pi, or psi is equal to 2n pi. Right? So sin n psi by 2 by sin psi by 2 equal to 0, for psi equal to 2n pi by n, but n is not equal to what? Is it okay? This is 0 when psi is this, but n should not be this value. Because if n is this value, then this also becomes. Or one second, sorry, it's not. Sorry, n should not be in this. N should not be. Okay, n should not be. right? So for nulls, psi should be in this form where n is not equal to n. So how many nulls we can expect for n antennas? How many nulls we can expect between 0 to 2 pi?